Okay, students. So today our topic is Mendeleev periodic table. Students, we were discussing about the historical development of periodic table. We have already studied two laws, Dauvergne triad law and Newland law of octaves in our last class, in our previous class. And today we will study about Mendeleev periodic table. Mendeleev, he was a Russian chemist, means he belonged to Russian. Was the most important contributor to early development of the periodic table. Means the periodic table which we are studying in these days that is known as the modern periodic table. It is based on the Mendeleev periodic table. Okay, Mendeleev periodic table has an important role for production, for formation of the modern periodic table that we are studying in this day. Okay, so Mendeleev periodic table was the important contributor to the early development of the periodic table. Okay, many periodic tables were made, but the most important one was the Mendeleev periodic table. Means Dauvergne tried. Dauvergne gave their assumptions. Newland also gave their assumptions. Some other, like Halleck's law, was also there. Means some other laws were given by different scientists. But Mendeleev have the important role in between them. Okay, so in 1869, after rejection of the Newland octave law, Mendeleev periodic table came into the picture. In 1869, Newland gave their law, Newland octave law, which we have already discussed in our previous class. What was the Newland law of the octaves? According to the Newland law of octaves, if we arrange the elements in order of their increasing atomic mass, that was the Newland octaves table. Elements were arranged in order of the increasing atomic mass. Then properties get repeated after a means property of first element and property of the eighth element with respect to the first. Their properties will be similar according to the Newland law of the octaves. But it had some limitations. What was the limitations? Because this law was applicable only up to the calcium, only up to the atomic mass 40 units. It was not applicable after calcium. Okay, so then Mendeleev gave us some points about the periodic table, about arrangement of the elements. So after Newland octaves law, Mendeleev came into the picture. In Mendeleev periodic table, elements were arranged on basis of the fundamental property, atomic mass and chemical properties. Means in Mendeleev periodic table, elements were arranged in order of their atomic mass according to their physical property as well as according to their chemical property. He arranged the elements. Okay. During the Mendeleev's work, only 63 elements were known. At the time of Newland, there were 56 elements. There were 56 elements discovered at time of the Newland. But at the time of the Mendeleev, there were 63 elements. How many elements were there? 63 elements at the time of the Mendeleev's. Okay. After studying the properties of every element, Mendeleev found that property of element were related to atomic mass in periodic way. Means he studied the compounds. He studied, sorry, not compounds, elements. Mendeleev studied these 63 elements and he studied about the properties of that and then arranged the elements in order of their atomic mass. He arranged the elements such that elements with similar property fell into the same vertical column of the periodic table. Means he arranged the element in this way that elements of same properties lie in same column, same vertical columns. This is known as the vertical column. Means the elements, let us consider A, B, C, D just, okay. So elements of same property, let us consider these are having same property, okay. So elements of same property exist into the same vertical column. He told us that. It is clear to you or not? Any doubt in this? Then among chemical properties, Mendeleev treated formula of hydrides and oxides as one of the basic criteria for categorization. What did he do? He made hydrides and oxides of elements. And on behalf of the properties of hydrides and oxides, he categorized the elements. If they have same properties, if the elements were forming same type of the hydride, same type of the oxides, then they kept them into the same vertical column. Okay, so he arranged the element in order of their similar properties. He took 63 cards and on each card he wrote the properties of one element. Because at the time of the Mendeleev, there were 63 elements discovered. So Mendeleev took 63 cards and he made write properties of one element at one card. Okay, then he observed that elements were arranged in increasing order of the atomic mass. After writing the properties of different element on each cards, he kept the cards or in order of the increasing atomic mass. In order of the increasing atomic mass. And there was the periodic occurrence of element with similar properties. Means when Mendeleev was arranging the elements in order of the increasing atomic mass, then their properties were, after some time I will take beta. Okay, happy birthday. So when he was arranging the elements in order of the atomic mass, then what was going on? The properties of the elements were repeated after an interval. After an interval of time, properties were repeated. Okay, so Mendeleev took 63 cards because at that time 63 elements were discovered. Then he wrote the properties of one element at one card. Then he arranged the cards in order of the increasing atomic mass of the elements. Okay, then he found that after an interval, properties are going to be similar. Properties are going to be repeated. Okay, students. Then, according to this observation, he formulated the periodic which state. According to this, that properties are going to repeat after an interval. So he gives us periodic law. Periodic law. On behalf of this assumption, he gave us periodic law. So what is the periodic law? The property of elements are periodic function of their atomic massage. Are periodic function of their atomic massage. Means after an interval, properties may get similar to each other. Okay, their property will start to match with each other. Okay, after a period. So he said that properties of elements are the periodic function of their atomic mass. This law is clear to you or not, students? Yes. Now, in Mendeleev periodic table, vertical column in periodic table and horizontal row in periodic table were named as groups and period respectively. What do you mean by this line? This was the Mendeleev periodic table. So here is the element in this way. There are some horizontal rows. These horizontal rows are known as the periods. They are known as the periods. And there were some vertical columns like this. These are the vertical columns. They are known as the groups. Vertical columns are known as groups. At the time of the Mendeleev gave us, there are 7 periods in his table. You can see one horizontal row is this. One, this one is 2, 3, then 4, then 1, 2, 3, 4. No, wait a minute, beta. This is 1, this one. This is 2, 3, 4, 5, 6, and 7. Okay, so there were 7 periods. There were 7 periods which were given by the Mendeleev to us. And how many groups were there? There were 8 groups. There were 8 groups. Means how many vertical columns? Vertical columns are known as the groups. So there were total 8. 1, 2, 3, 4, 5, 6, 7, 8. Clear or not? Any doubt in this? Okay. So students, you will keep some things, some points in your mind. First one, at Mendeleev time, there were how many elements? 63 elements. He gave us that there are total how many periods? 7 periods in Mendeleev periodic table. And there are 8 groups. And there are 8 groups. Okay. But this table has important role in development of the modern periodic table. After a while, it had some limitations. So what was the limitations of what was the demerits of the Mendeleev periodic table? We will see in this topic. Merits of first of all, we will see about the merits. What was the merits? Means what was the significance of this table? Significance, some gaps were left for the element yet to be discovered. Students, at the time of the Mendeleev, some elements were not discovered at that time, but Mendeleev kept gap for them also. Some elements which were not discovered at that time, but Mendeleev kept gap for them. So this was a big assumption, big merit of the Mendeleev periodic table. Okay, at that time under aluminium, he left gap and he gave name that Ica aluminium. And under the silicon, he also left gap and gave name to this Ica silicon. And now we are studying those elements, Ica aluminium in gallium form and Ica silicon in germanium. Means Mendeleev predicted gallium and germanium when they were not discovered at that time. It is clear to you or not? Then, thus if a certain new element is discovered, it can be placed in a new group without disturbing any exciting group. Means he made the table in this way. If some elements will be discovered in future, then we can set them, we can arrange them in between the table without disturbing the table. Clear or not? Okay. Now, what were the demerits of the Mendeleev periodic table? Why do we need to form modern periodic table? Because there were some limitations, there were some demerits of the Mendeleev periodic table. So what were the demerits? First one was, he was unable to locate hydrogen in periodic table. Students, he did not give the exact position of hydrogen. Students, I want to say that this is the limitation of modern periodic table also, because hydrogen have unique nature, it has anomalous behavior. Even we are keeping it in first period, but it is not the right position of the hydrogen in modern periodic table also. That was also the limitation of Mendeleev periodic table. He did not locate the hydrogen in periodic table in a fixed place. Okay, then increase in atomic mass was not regular while moving from one element to another. Students, you know very well what is the atomic mass of hydrogen. It is 1. Now our second element is helium. Its mass is 5 4. Then lithium. What is the atomic mass? 7. Beryllium. 9. Boron. 11. Then carbon. 12. Then nitrogen. 14. Oxygen. 16. Fluorine. 18. And oxygen. Sorry, not oxygen. Neon. You can see from here also. Here you can see gap between atomic mass of hydrogen and helium is 4 minus 1, 3. Again here 7 minus 4, it is 3. Here 9 minus 7, 2. Here 11 minus 9, 2. Here 1 only. Okay, means you can see that this gap is not regular. This gap is not regular. Somewhere it is 3, somewhere it is 2, somewhere it is 1. So how can we predict that how many elements we can fix in between them? Because Mendeleev gave his table in order of the increasing atomic mass. He gave the table on behalf of the atomic mass. And he left some gap, okay, for the elements which were not discovered at the time of the Mendeleev. So how can he say that how many elements we can fill in between them? Because there is not regular gap. There is not regularity in atomic mass of the elements. So it was also demerit of the Mendeleev. This limitation is clear to you? Okay. Now, later on, isotope of element were found which violated Mendeleev periodic table, Mendeleev periodic law. You know very well what are the isotopes. What do you mean by isotopes? What do you mean by isotopes? Atoms of the same element. Which have same atomic number but different atomic mass. Like carbon, C6, 12, 13, it may exist in C6, 14. Here all are the elements of the carbon. Atomic number is same here, but mass number is different. Mass number is different. At the time of Mendeleev, they were not predicted. But when they predicted, Mendeleev law is not applicable for that. Because which one mass we can take? Because Mendeleev periodic table was discovered on behalf of the atomic mass. Okay. But here atomic mass is different for same element. So which one we will take? It is also violated the Mendeleev periodic law. So this is all about the Mendeleev periodic table. Do you have any doubt in any point? If you have any doubt, you can ask to me. Clear to you? Okay. So thank you. Have a nice day.